channel?
Affirmative.
Telemetry and launch condition?
Affirmative.
Missile and internal DC?
Affirmative.
This is where the United States took its first step with man into space. He was Commander Alan Shepard, launched from here, Pad 5-6, on May 5th, 1961. The National Space Program has come a long way since then. This launch complex, originally built for the Army's Redstone missile, was later used for our first space flights. A short distance from the pad is the blockhouse from which Alan Shepard's flight was controlled. It's deserted now, and most of the launch equipment has been removed. These pads, which the Air Force has transformed into a museum, were soon outmoded as larger rockets were developed. Thus, a facility which was of significance in launching the first American into space is today, just a few years later, part of history. The success of those early space flights from these pads motivated President Kennedy in 1961 to lay down the challenge to land astronauts on the moon by 1970. This unprecedented project required a new and larger launch area. By 1961, with the construction of the Saturn launch facilities, most of the space for launching vehicles on the Cape had been taken up. NASA had to look elsewhere for a lunar rocket launching area. After careful consideration, an 88,000-acre site was selected on Merritt Island, across the Banana River from Cape Kennedy. There, enormous forms of concrete and steel have risen from Florida sands to shape the new launch facilities for the first operational spaceport. On the once wind-swept marsh and swampland of Merritt Island, Florida, America's resources of industry and science are focused on the lunar goal set by the late president. Here at the Kennedy Space Center, about 21,000 dedicated and skilled Americans operate the nation's spaceport. Many work in the industrial area, which contains the management, engineering, and support elements for the launch complex. From the Kennedy Space Center headquarters building, nerve center of the sprawling spaceport, a government industry team operates the space-age community. About 2,800 of the workers at the Space Center are government career employees. Several thousand others work for launch vehicle and spacecraft contractors, the giants of American industry involved in the Apollo Saturn V lunar landing program. Other contractor employees perform the support services needed to keep the spaceport operating efficiently. Special purpose buildings have been constructed to carry out highly specialized tasks. In the Manned Spacecraft Operations Building, Apollo spacecraft are carefully prepared for flight. 200-ton stainless steel chambers test the spacecraft at simulated altitudes up to 250,000 feet. Space-suited astronauts participate in the detailed operations associated with the preparation of Apollo spacecraft for a mission. The command module is subjected to thorough testing of its complex instruments and controls, which the astronauts use to pilot their spacecraft. High-speed computers in the same building test the complicated systems of the spacecraft. Living quarters for the astronauts are also conveniently located in the Manned Spacecraft Operations Building. At the astronaut training facility, spaceflight missions are rehearsed in the Apollo spacecraft simulator. It can electronically duplicate an entire trip to the moon and back and is used to prepare astronauts for various space missions. Skilled technicians program flight conditions into the simulator with computers, which provide realistic training for astronauts. A unique structure called the Timber Tower was erected to test radar and radio equipment of spacecraft scheduled for flight. Rendezvous and docking is also practiced by the astronauts at this facility. In this building, the weight, balance, and center of gravity of the spacecraft, including the astronaut and his contour couch, must be critically determined. Technicians give careful attention to every detail of this important phase of testing. A series of special buildings called the Fluid Test Complex is used for testing toxic or explosive fuels for spacecraft maneuvering thrusters. Special suits protect the fuel handlers during these operations. And in this building, the safe descent of the astronauts from space is assured by careful control and inspection of the spacecraft parachutes. Specialists prepare, fold, and pack the chutes on a table 180 feet long. At the Central Instrumentation Facility, high-speed computers can receive data during preparation and launch of space vehicles at the rate of 36,000 pieces per second. Store 432 million bits of data. Retrieve and print out processed information at 2,400 lines per second. And transmit the data to Marshall Space Flight Center and Houston Manned Spacecraft Center. North of the industrial area at Launch Complex 39, gigantic structures dominate the scene. The 360-foot-tall lunar rocket requires huge assembly, checkout, and launch facilities to accommodate its size and power. Mobile launch towers that reach 44 stories into the sky. rocket support platforms, half the size of a football field. Crawler transporters, powerful machines to lift and move the towers into the vehicle assembly building, where the Apollo Saturn V will be assembled on one of the mobile launchers. And a special roadway on which the crawler transporter will carry the launcher and the fully assembled rocket to the pad, 3 miles away. Here on launch day, man will begin his greatest adventure. The explosive potential of the fuels needed for the lunar rocket and the high noise level of the engines prohibits launching near populated areas. Anticipating the day when the powerful rocket will be launched, planners of the spaceport provided for large areas of land to serve as a safety zone. Part of this area is a wildlife refuge managed by the Department of the Interior's Fish and Wildlife Service. Some of the beaches of the spaceport are open for public recreation. Orange and grapefruit groves, which the space agency purchased, have been rented to the former owners who continue to operate them. Because of this extensive safety zone, the Space Center can safely launch its lunar rocket and has ample room for expansion if required by future, heavier vehicles. These buildings, towers, and transporters reflect the mobile concept, a new method of launching heavy rockets. Until now, NASA launch vehicles were assembled and checked out on their launch pads. This meant the pad was occupied for several months before each flight and limited the number of firings which each facility could accommodate. Possible corrosive effects of salt air on the launch vehicle and hurricanes at times have created special problems. The new method stresses mobility and permits more launches from fewer pads. The launch area for the lunar rocket is primarily a fueling stop. Large tanks about a quarter mile from the pad store the fuels for the powerful rocket engines which develop 7.5 million pounds of thrust at liftoff. An open trench and steel deflector contains and dissipates over 7,000 degrees of heat from the flaming rocket exhaust. There is no permanent service structure on the pad. Instead, the launch towers and structures will be moved. This is a major requirement of the new concept. Almost everything is mobile. The 402-foot-high service structure, for example, will be transferred to the pad by the transporter to service the Saturn vehicle. 5 adjustable platforms located at convenient levels provide technicians with complete access to the rocket. The new launch platform, which has all of the equipment of a fixed launch tower, can also be transported. The launch tower provides access to the vehicle and supports the lines which carry fuel, power, and communications cables to the rocket and spacecraft. 9 service arms, which extend from the tower, complete the connections to the vehicle and provide access for technicians. Inside the steel base of the launcher are 2 floors of intricate electronic equipment that controls and monitors the preparation of the launch vehicle and spacecraft. The large opening in the launcher base allows the exhaust flames from the Saturn V to pass through and hit the flame deflector on the pad. These hold-down arms clamp to the base of the launch vehicle and support it during assembly, checkout, and transport. At launch time, The arms restrain the vehicle for several seconds after ignition until computers determine that sufficient thrust has built up for liftoff. The key to the mobile system is the powerful 3,000-ton transporter that must carry a 12-million-pound load, the combined weight of the mobile launcher and the unfueled lunar rocket. The power to perform this task is produced by two diesel-electric generators controlled from an operations room. Two driver cabs, one on each end of the vehicle, are necessary to steer the enormous crawler. Each crawler tread is powered by 16 electric motors. Just one shoe in the track weighs about a ton. The total weight of the transporter and its cargo is 18 million pounds. This massive load requires a special road or crawlerway. The base is 7 feet thick in places and as wide as an 8-lane superhighway. The vehicle assembly building where the Apollo Saturn V is put together is 52 stories high and covers 8 acres of land. This building can withstand winds of 125 miles per hour and will be a safe refuge for the launch vehicle during a hurricane. It is a big structure, but it is also a precision tool, a tool that is necessary for the assembly and checkout of a lunar rocket as tall as a 36-story building. The launch team can watch the Saturn lift off through these giant windows in the Launch Control Center. This is one of the 4 firing rooms, which will be occupied by equipment and men who will control every phase of the preparation and launch of the Saturn. The firing rooms correspond to the high bays of the vehicle assembly building, where the huge rockets are assembled. Because of its unusually large size, the first stage of the Saturn V rocket is transported to the spaceport by barge. A man-made waterway from the ocean to the spaceport allows direct delivery of the stage to the vehicle assembly building, where it will be erected vertically on a mobile launcher in one of the high bays. Inside, the rocket section is lifted by overhead bridge-type cranes, which then slowly and gently lower the 138-foot-long stage to the deck of the launcher. Work platforms as large as 3-story buildings encircle the Saturn to give technicians access to various sections of the vehicle. The 2 upper stages of the rocket, after initial checkout, are then moved into the high bay area as the assembly of the space-age giant continues. The 82-second stage weighs 80,000 pounds empty and over 1 million pounds loaded with fuel. The Saturn V's 3rd stage will place the astronauts in an Earth parking orbit 100 miles high, the first leg of the moon journey. Complex electronics housed in a circular instrument unit will guide and control the rocket during flight. A 3-section payload, including the Apollo spacecraft, which will carry men to the moon, is then placed on the booster. Finally, the launch escape system, designed to pull the astronauts to safety, is added to the spacecraft. Completely assembled, the space rocket stands 365 feet high. When the Saturn V is ready, a transporter lifts the launcher and space vehicle from support pedestals and moves through a doorway 45 stories tall. Then the first 3 miles of the moon voyage begin. The space vehicle, taller than the Statue of Liberty, is a tribute to the skilled work of thousands of the nation's industrial firms and represents the combined technological effort of all of NASA's centers throughout the country. The journey to the launch site at 1 mile per hour is the last scheduled earthbound movement of the lunar rocket. The crawler, inching its way to the pad, must keep its 450-foot-high cargo level, compensating for wind and shifting weight. Halfway to the launch site, the Apollo Saturn V passes the mobile service structure, which will later be moved to the pad for final servicing of the rocket. As it moves up the grade to the top of the launch site, hydraulic cylinders level the load. Slowly, after hours of careful transport, the rocket approaches the launch pedestals. The transporter then lowers the mobile launcher to the concrete and steel supports that will place American astronauts on the surface of the moon in this decade. Our nation today stands on the threshold of a great adventure, the first exploration of another planet. Many impressive milestones in manned spaceflight have been accomplished since Commander Alan Shepard climbed aboard a Mercury Redstone rocket for his short ride into space. The development and use of larger and more powerful space vehicles have placed our astronauts into orbit around the Earth. First alone in a Mercury capsule, and then in pairs with Project Gemini, remaining in space longer than the time it takes for a round trip to the moon. Astronauts have walked in space. They have rendezvoused and docked with other spacecraft. Performed useful work in space, and have flown to an altitude of 850 miles. Yet, these impressive achievements were but necessary steps in the development of a complex spacecraft technology for interplanetary travel. When 3 American astronauts leave their home planet on the historic lunar voyage, they will in reality open a doorway to tomorrow, where unknowns in space are waiting to be discovered.